Hello, everybody. Welcome back. Today, we are going to be looking at applying some of the skills that we've been working on in our previous lessons. We looked at what slope is. We looked at how to determine slope from a graph by the rise over the run. We looked at using the slope formula, which is the change in y divided by the change in x. And then in our previous lesson, we looked at taking information from a table or from a chart and plugging that into the slope formula to figure out the slope or the rate of change. Now today we're going to be looking at some applications of how this works in real life and why you would actually need to know how to do this. That's the question that math teachers always get asked. It's almost verbatim, Mr., when am I going to need to know this? Mr., when am I going to need to be able to do this? Like, Mr., why am I learning this? Well, today's lesson, this is why. So let's get into some applications. Now, so for today's lesson, we're going to be using this chart right here. And this chart tracks over a 2-week span some of the changes in temperature in the month of June. So on the June 1st, it was 72 degrees. On June 6th, it was 76 degrees. On June 8th, it was 84 degrees. And then on June 14th, it was up to 86 degrees. Now, looking just at this table, I notice that it doesn't go 1, 2, 3, 4, 5, 6, 7, 8, 9. Like it skips, it just picks out specific days from the month of June. So what we're going to be looking at today is over a couple of these different time spans, what was the daily change? We're going to assume that from the 1st to the 6th, that when it went from 72 to 76 degrees, that it grew steadily and it grew at a pace. It may have gone like this. It may have jumped all the way up to 97, down to 22, and then back up to 76. But we don't know that. All the information that we're given is what's in this table. So let's look. So we're going to find first the rate of change in high temperatures, and this is the high temperatures. So because we know that every day there's a low temperature and there's a high temperature. So this is the high temperatures for each of these days in June. So first we're going to look at the rate of change in these high temperatures between the 1st and the 6th. So we have, if we look at this like coordinates, the dates would be our x coordinates and the temperatures would be our y coordinates. So on June 1st, the temperature was 72 degrees. On June 6th, the temperature was 76 degrees. So I pulled those two numbers out and I actually wrote them here as coordinates, 172 and 676. So in doing that, coordinate 1 is June 1st. Coordinate 2 is the information about June 6th. So I plug that into our slope formula. So I take y2, which is, I'm going to pull out my little annotation tool here. So my y2 is 76, my y1 is 72. So I subtract 76 minus 72 right here. And then my x2 is 6, my x1 is 1, so then I have 6 minus 1. So 76 minus 72 divided by 6 minus 1 gets me 4/5, or if I change this to a decimal, about 0.8 of a degree or 0.8 degrees per day. So the rate of change, so if I assume that this goes steadily, that every day between June 1st and June 6th, the temperature grew by 0.8 degrees. So the next one we're going to look at the next interval, which is just a 2-day interval between June 6th and June 8th. And we see that the temperature jumped from 76 degrees all the way up to 84 degrees. So using the same information, the same way that I did before, I'm going to do the change in my temperature, or the change in y, divided by the change in x, or the change in the number of days. So I have 84 degrees minus 76 degrees over 8 degrees minus, or 8 days minus 6 days, giving me 8 over 2, or 4 degrees per day. So previously we grew by 0.8 degrees per day, and then between the 6th and the 8th, there must have been a heat wave, and it jumped to 4 degrees per day. Now, the last question is asking us, during which of these intervals did the temperature rise the fastest? So is it between the 1st to the 6th, the 6th to the 8th, or the 8th to the 14th? Well, going back into what I already did, I know that the interval from the 1st to the 6th was 0.8 degrees per day. And from the previous slide, I know that from the 6th to the 8th, it grew by 4 degrees per day. The only one that I don't know is from the 8th to the 14th. So how do you think I'm going to find that? If you said plugging your information into the slope formula to find the rate of change, if you said that either out loud, you said that in your brain, or you thought it, then you were correct. So I'm actually going to do this in the reverse order because I've said this in every video so far. It doesn't matter the order of which coordinate I choose as my coordinate 1, which coordinate I choose as coordinate 2. It doesn't matter the order. What matters is once I choose that, how I plug that information into the slope formula. So I'm going to keep June 14th, 86 degrees as coordinate 1, and then I'm going to have June 8th, 84 degrees as coordinate 2. So I'm going to plug this into my formula. I have the change in degrees, 84 minus 86, over the change in days, 8 minus 14. And that gives me negative 2 degrees per negative 6 degrees. Now, when I am multiplying a negative times a negative, my answer is positive. When I'm dividing a negative by a negative, my answer is still positive. Remember, 2 negatives or 2 positives give me a positive answer. It's only when I have opposite signs, either a negative in my numerator or a negative in my denominator, that my answer would be negative. I look back at my chart to see if this makes sense, and I look 72, 76, 84, 86. My line is constantly going up. My line of temperatures is in a constant, it's moving in a positive direction. So negative 2 divided by negative 6 gives me positive 1/3, or about 0.33 degrees per day. So if I look back at what the question is asking me, I look and it says, okay, during which time interval did the temperature rise the fastest? I've got 0.8, 4 degrees per day, or 33. So I know that the interval when it rose the fastest was between the 6th to the 8th. So what is it that you have to do today? I'm going to clear this, and I'm going to show you what it is you actually have to do for today's assignment. And here we are with what we have to do. So each of you is going to be given a sheet that looks something like this. It has 2 parts plus a bonus. So I wanted to show you so that you can see actually what it is that you have to do. So for questions 1 through 4, you're going to be using this table. So I'll get my little spotlight tool. So it says that in 2002, I went on a diet for 9 weeks and decided to record my weight every other week. So we have week 0, week 2, week 4, week 6, week 8. So the interval that we're given is every 2 weeks or every other weeks. So I put in week 0 because week 0 would be like day 1. This is where I'm starting out. So all you really have to do, this is asking to find the rate of change from the 1st week to the 2nd week, from the 2nd week to the 4th week, from the 4th week to the 6th week. And then if you look at Question 4 it is slightly different. It's asking you what you notice about the change from week 6 to week 8. So this is asking you not just to do math, but to make a prediction. I'm not actually asking you to solve anything in question 4. What I want you to do is to look at the data, look at the chart that you're given, and tell me what you think it means. What is the meaning behind these numbers? It's put in here like you're given some background. You know that one part of the chart is the week, one part of the chart is my weight. So looking just at the numbers, what can you determine? What do you notice about the numbers specifically there? So what is the meaning behind these numbers? Now, for part 2, you're going to use the information in the word problem simply to find the rate of change or the slope between any 2 points. So for number 5, Jaslyn earned a 94 in the first term, an 86 in the second term, an 88 in the third term, and a 96 in the fourth term. So be careful because this is asking you to find the rate of change from the second term to the fourth term. Okay? Keep that in mind. You're not just finding all of them. It's how she changed from the second term to the fourth term. And our last one is all about Justin. He decided last Wednesday to go hiking. At 11 o'clock in the morning, he was in an elevation of 500 feet. By 3 o'clock, he was in an elevation of 900 feet. So you're trying to find the rate of change in elevation, and your answer should be in feet per hour. Now, I also gave you a bonus. Ask you a car that was worth $27,500 in 2012 in 2016 is worth $16,720. What's the rate of change in the value of the car? And be careful with this one. All right. Like always, if you have any questions or you come across something that you don't fully understand, call me, text me, send me a message in Dojo, send me an email, something, because I really want to be able to help you to understand this before you move on to Algebra 1. Okay? Today is an application of the slope formula in some kind of real world situations. So have a wonderful rest of your day. And like always, if you need something, if you have any questions, please come and find me. Have a great rest of your day.